Hello everyone. In this video we are learning what is the purpose of concurrency control. Concurrency control is a database management feature that manages multiple users making changes to a database at the same time, without causing inconsistencies or integrity issues. Let's say you and your sibling are both using banking app to transfer money from the same joint account. You both see $1,000 in the account. You transfer $700 and your sibling transfers $500 at the same time. Without concurrency control, the system might allow both transactions, leading to a minus $200 balance, which shouldn't happen. With concurrency control, the system ensures one transaction completes before the other starts, avoiding inconsistencies. Concurrency control aims to preserve data integrity, isolate transactions, and prevent inconsistent retrievals. Preserve data integrity prevent issues like lost updates, where changes from one transaction might overwrite another, and ensures accurate data. Imagine you're using a food delivery app. Without data integrity, you order from a restaurant that no longer exists in the system. Your order shows a total of $20, but charges you $0. The restaurant receives your order, but your address is missing. Two orders have the same order ID, confusion everywhere. How data integrity helps. Entity integrity. Each order has a unique ID. Referential integrity. Every order references a real customer, restaurant, and delivery person. Domain integrity. Payment method must be valid, e.g., not accept a blank card number. User-defined integrity. Discounts applied only if conditions are met, like first-time user. Isolate transactions ensures each transaction is executed in isolation so that they do not interfere with each other. For example, when Sarah starts booking, the system locks the room for her. John's booking is paused or blocked until Sarah finishes. If Sarah finishes first, John sees room unavailable. Prevent inconsistent retrievals ensures data is read accurately during concurrent transactions, avoiding erroneous data being accessed. For example, imagine you're checking your bank statement to see how much money you spent this week. While you're checking, some new transactions are being added or updated, like a refund or a late charge. You might see some of the new transactions, miss others, or even double count something. With proper isolation, preventing inconsistent retrievals, the system locks the data or gives you a frozen snapshot while you're checking. So even if someone updates in the background, you see a consistent picture.
Concurrency control have three problems. The following problems are lost updates, uncommitted data, and inconsistent retrieval. Lost updates is a concurrency control problem in which a data update is lost during the concurrent execution of transactions. Happens when two transactions update the same data at the same time, and one update overwrites the other, causing the first update to be lost. For example, imagine two admin staff updating a student's record at the same time. Admin A changes the student's address to Kuala Lumpur. Admin B at the same time changes the student's phone number. But both are working on old copies and saving at the same time, so one of the updates gets lost. Uncommitted data is a concurrency control problem in which a transaction accesses uncommitted data from another transaction. Uncommitted data is a problem where one transaction reads data from another transaction that is not yet committed, and the first transaction ends up failing. For example, an employee is entering a payment amount into the system but hasn't pressed save yet. Meanwhile, another staff uses that amount to print a receipt. Suddenly, the first transaction fails or is cancelled. As a result, the receipt contains invalid or incorrect data. Inconsistent retrieval is a concurrency control problem occurs when a transaction accesses data before and after one or more other transactions finish working with the data. Inconsistent retrieval occurs when a transaction reads part of the data before another transaction finishes updating, and another part after it finishes, causing inconsistent data to be retrieved. For example, a cashier is checking stock. They read stock in as 100 units. While checking stock out, another staff is updating it to 50 units. So the final stock appears incorrect, inconsistent. For the solution to these problems, we can use a scheduler. The scheduler is the DBMS component that establishes the order in which concurrent transaction operations are executed. The scheduler interleaves the execution of database operations in a specific sequence to ensure serializability. The purpose of the scheduler is to avoid conflicts between transactions, maintain data consistency and integrity, ensure all transactions appear as if they happen one by one, even if processed simultaneously. The scheduler is a component in the DBMS that arranges the order of transactions, decides when a transaction can read or write data, and prevents overlap and data conflict. Example of scheduler's role is: makes sure transaction A finishes first before transaction B can access the same data, prevents two users from modifying the same data at the same time. Queue number system at the bank: customer A wants to withdraw money. Customer B wants to change their address. Customer C wants to pay bills. Without a queue system, everyone rushes, the counter data might get mixed or lost. With a queue, like a scheduler, each customer is served one at a time in a proper order. Thank you for watching. We hope we help you understand what is the purpose of concurrency control.